working with oil sands substrates. That we hear today that oil sand has a lot of waste materials. So in this case, I am trying to use them as a reclamation substrate. So I'm going to start talking about what are the materials that I am working with. Then I'm going to see some issues of the reclamation with these materials. And later I will go with my research objectives, the methods, the results, and some preliminary conclusions. So well, first I work with mature fine tailings. So I'm called MFT. So mature fine tailings are silt and clay material that is suspended in water, and they have high concentrations of sulfur, sulfate, and also has some chlorine and another compounds that could be phytotoxic for plants. So at the picture we can see that mature fine tailings are deposited on tailings ponds. So here we have the tailings ponds. At the top layer we have the water, then the thin fine tailings, and then the mature fine tailings. So another byproduct that I am working is the petroleum coke. And petroleum coke is high in carbon content and also has high concentrations of sulfur and has traces of heavy metals. So there is some plant limitations for plants that grow in on these materials. So there is the high salinity, high crusting, low nutrient concentrations, low water retention, low soil aggregate stability, and low organic matter. So we are dealing with these limitations in reclamation with these materials. Some of the current tailing scenarios that they are dealing with now is the long time between the disturbance and reclamation certificate. So there is there's long time between these two options. And also there is the extensive tailing distribution systems and the large tailings ponds. So to have an idea how is the volume of these materials is being 705 millions of cubic meters deposited on tailings ponds nowadays. And also carbon petroleum coke is produced at 5,000 tons per day on site and deposited on site. So some of the tailings reclamation options that they are trying to use these materials, they are doing the tailings reduction operation that works with MFT. So they add polymer flocculant to the MFT. So the clay particle attached to this polymer, and then the water separated from this. And I am working in this research with this mature fine tailings dry. And also they are using capping materials over the MFT or over the coke, and also they are mixing MFT with overborder and mixing with coke. So there are some options that they are using now in reclamation. Now I'm going to my research objectives. So my overall research objective is to determine if MFT can be ameliorated for plant growth and in different proportions of petroleum coke, tailing sands, and peat mineral mix. And the specific objective is to evaluate emergence, growth, development, survival of native plant species in coke and MFT mixes. And also determine the effect of coke addition and rate of MFT chemical and physical properties. Some of the methods that we use: first, we did a greenhouse experiment with these mixes, with these substrates. So we used a complete randomized block design, and we kept the conditions of the greenhouse constant for overall all the experiment from 16 degrees to 21 degrees. And the experiment was 16 weeks in length. The MFT was air dried and also grind and sieved at 19 millimeters, and the coke was ground to 4 millimeters. So we had 4 four treatments of MFT. So 100% MFT and tailing sand in 50 and 50%, MFT, tailing sand, and peat mineral mix in this proportion, MFT and peat mineral mix in this proportion too, and we had two reference treatment that was 100% coke and 100% potting soil. And for this treatment, also we add different rates of coke on these mixes. So we had four different rates. That was 0, 10, 25, and 40. So we had the treatment of the substrate and the addition of coke. And the control was MFT 100% without any coke addition. Some of the grass species that we use, we use Allinus tachycalus, Agrostis scabra, and Festuca saximontana in a mix. So we planted a mix of them, like 10 seeds per each species in one pot. And we replicate all the treatments 5 times, so we had a total of 90 pots. Some of the measurements that we did on vegetation and soil chemical, sorry. So we measure density and health every week, and we measure hair cover and biomass, and all of the other two at the end of the experiment. And for the soil chemistry, we measure available nutrients, salinity, chlorides, heavy metals, and hydrocarbons. So these measurements we did before and after the greenhouse experiment. So we did another experiments too to see what is the holding capacity of these substrates, and also to see what is the hydraulic conductivity, but I'm not showing these results here. So the methods that we use, because of the data mostly was no normal, we use the permutation-based multivariate analysis, called PermaNova, and we use pairwise state multiple comparison, a redundancy analysis, called RDA, and variation partitioning analysis. These two mostly to see the chemical parameters in comparison with plant growth. Some of the results that we show now is that here we have the seedling emergence on the y-axis, and we have it on the x-axis the days after seeding. So this is the time. And so in red here we have the 100% coat treatment, and this was the 100% MFT treatment. So the plants didn't grow very well on these two treatments, but the best mixes that we found were this one, that is peat mineral mix with MFT, that was that, and also this one, that is MFT, tailing sands, peat mineral mix. So the mixes that has some organic matter was the best performer on this with seedling emergence or plant growth. For above ground biomass, we show here in the y-axis, we seen, and also on the x-axis, we have all the treatments. So again, here we have like the best treatments were those who has on the mix, peat mineral mix or organic matter. We only found significant difference on the treatments, but not on the coke rate. And here you can see some of the mixes were performed better than others, but didn't show, sorry, some of the coke rates didn't show any result like there is a significant difference between them. It's not, only with treatments. So here also some of the worst performance treatment was the MFT tailing sand. Well, the coke 100% was not very good, but even that happened because sometimes the materials were not a good water retention, so the plants would have some water stress on this treatment. So to see what happened in terms of the plant species, we saw that Elymus trachicalus was the most tolerant species, and also Festuca saximontana. So in all the treatments, Elymus has the best performance, but Agrostis scabra didn't grow on coke or didn't grow in 100% MFT, neither in MFT tailings and 50-50. So Agrostis scabra was the most affected plant for those materials, the coke and the MFT. To see what happened in terms of the chemical parameters with the plant growth, we did the RDA analysis. So in this analysis, we used the three responses variables, that is the above ground biomass, cover, plant cover, and density as responses, and how it's related with the chemical parameters. So in this graph, we can see that the arrows here, the angle between the arrows also shows a correlation between the other variables. So above biomass is negatively correlated with mostly hydrocarbons fractions, and also, for example, here in density is most negatively correlated with B-tex compounds, and also, for example, here cover is also correlated with heavy metals in this case, like molybdenum and others. So the treatments in here, we have that we are going from MFT 100%, that is the blue one, and coke, that is like this one. So in the middle we have all the mixes, but mostly what said this analysis is the relationship between the response variables and the parameters here with the angles. To see what happened in this analysis and the previous analysis, to see what happened between the interactions between these chemical parameters, we did this variation partitioning analysis. So we grouped many of these chemical compounds, so we group as salinity parameters, we group as nutrient, exchangeable ions, salinity, trace elements, and hydrocarbons. And we are trying to see what is happening by themselves, how they affect plant growth, or what happened with the interactions between them and how they affect plant growth. So we found that, for example, here the salinity parameters only by themselves explain 7% of the plant growth, and also the interaction between trace elements and hydrocarbons explains another 6%, and trace elements with nutrients another 6%. And the interaction between every of them explains another 6%. So the summatory of these percentages of these analysis give us an idea what is happening with this chemical parameters and plant growth. So it's to have an idea also that interactions between them are also interesting to study, not only what is the amounts of chemicals that we have. So as a preliminary conclusions, we can say that plants can grow in treatments with coke, but the growth is not big. It's not big like the other treatments. And plant growth was inhibited with high concentrations of coke and high concentrations of MFT. And the Elymus trachicalus and Festuca saximontana were the most tolerant species on all the experiments. And the treatments with high proportions of coke had salinity parameters and trace elements that could be detrimental to plant growth. and treatments with coke and high hydraulic conductivity done with, treatments with coke had a high hydraulic conductivity done without coke. This we show, I am telling you this because these results also affect some plant growth, because the treatments that have high hydraulic conductivity didn't have like the water holding capacity to retain this water, so the plants express as water stress on them. So yeah, that is. So I would like to acknowledge to the funding institutions that funded my research, that is Suncor, Energy, University of Alberta, and CONICET, that is the government of Chile. Thank you for the people that is helping me in all my research thesis. Thanks. Thank you.
Do we have any question for Gabriel?
No, it's typical that saline is with oil or microfine tailings.
Mm-hmm.
It is. Now, how is, like saline is a salt, so it could only be leached out, eh?
It's hard to say. Sometimes there are interactions between them. In this case, with the major fine tailings and coke, because they have different concentrations. For example, in major fine tailings, they have more salinity or sometimes more sulfate. And in another case, for example, coke have some of the trace elements. So it's hard to say what is happening in terms of interactions between them and how is it affecting.
So coke is actually an adjuvant to saline. It helps to mask it, does it?
Yeah, but in this case, this coke that is produced on the oil sand upgrading, like the bitumen upgrading to synthetic crude oil, is like they have more sulfur in this like concentration.
But not as much. And
yeah, so it's not the same effect.
Would the sulfur act with the saline or not?
Yeah, also some.
So
yeah.
It could counteract against the saline sulfur.
Yeah. For example, they're trying to use these mixes because also the major fine tailings, there is a lot of clay on major fine tailings. So the material is to improve the water infiltration. They put coke. In this case, the coke helps for water to go on and maybe could be more available for plants. That is one of the thoughts of doing the hypothesis for doing this. Yeah, but have different interaction between the chemicals and the physical soil properties.
Go ahead.
Did you measure the soil pH?
Yeah.
And what is the range?
We didn't find any problem with the pH. What the range was 6 to 5 or 6 to 5.
Almost neutral.
Yeah, so it was a.
Would you deal with BKA at all?
Sorry?
That's what with ammonia, like as the I guess amine. Would you deal with BKA at all, or just with pH?
Just pH.
pH.
Eric?
I might have missed this, but can you explain what coke is as a waste product from oil sands a little bit more?
Yeah, it is petroleum coke is a waste product or byproduct of the oil sand. It's produced on the upgrading process for the crude oil, for the synthetic crude oil, the bitumen to synthetic crude oil. That is, so it's the coke has high concentrations of sulfur in this case, and also it's high in carbon content.
Is it a mineral substrate or an organic substrate?
It's organic, because it's a byproduct of this process of hydrocarbons.
We'll take one last question.
Okay. I don't know if you measure other physical parameters for that.
In soil?
Yeah, techniques.
Yeah, but I'm not showing in this. Yeah, but we measure hydraulic conductivity, we measure your water holding capacity?
No, I have a parallel. Like alkali soil will support growth of certain plants. I'm not sure which one it is, alkaline soil, but the pH would be very high in alkaline soil.
Yeah, but in this case, the pH was not a problem.
The pH in the oil microfine tailings would be 6 or something, or 5. 6 supports growth quite well, but 5 or 4 would be.
Yeah, yeah, in this case, yeah. But it also that like
I'm
the pH
interested in soil science.
Yeah. Can you discuss with her later if you want to? It's 1:40, we'll move to the next one. Sorry for that. Thank you very much. Can you please join me to say thank you to Gabriel?